Let's continue with the test review, page 28. We're asked to use reference angles to find the exact value of the expression. On your test, you're actually going to have to show these middle steps. The cotangent of negative 45 degrees is the negative cotangent of 45 degrees. At 45 degrees, my cotangent is my x over y. I have a negative, this is 1, so it simplifies to negative 1. The secant of 9 pi over 6. 9 pi over 6 is 1 full revolution plus 7 pi over 6. The point at 7 pi over 6 is right here. So from 7 pi over 6, my reference is actually, because it says to use the reference angle, my reference angle is pi over 6. So my secant, where that ends, is going to be at a negative, and at pi over 6, secant is going to be 1 over my x value of root 3 over 2. When I simplify that, I get 2 over root 3. 2 over root 3 is 2 root 3 over 3, and remember it is negative. So for that intermediate step, I would say the secant of 19 pi over 6 is the negative secant of pi over 6, which is negative 2 root 3 over 3. Now for graphing, you will have to graph one function on your test. Let's take a look at doing a couple of these. Here's the sine of theta. To get these points, pi over 2 pi, 3 pi over 2, and 2 pi, I look at the y value of my unit circle. My amplitude is 1, my period is 2 pi. Now I'm going to change this so my amplitude is 4. So you will see it is stretched out a little bit further. Now to calculate the period, 2 pi over b, so now my x-axis has changed. Instead of going from 0 to 2 pi, I'm going from 0 to pi. Right in the middle is going to be pi over 2, and then my other midway points. Now my entire graph has moved up by 1. So let's compare. At 0, I've moved it up 1. Where it would have been at 1, I'm going to multiply it times 4 and add 1. So this has moved up to 5. Down here, instead of at negative 1, I multiply times 4. To get negative 4, move it up to be negative 3. Cosine starts high and goes low. 1, 0, negative 1, 0, and 1. My amplitude is 1, my period is 2 pi. Tangent is, your amplitude on this one is 1, my period is pi. So between negative pi over 2 and pi over 2, this is the period of 1. This is the snake in the road. These are your lane markers. Midway at pi over 4, the value for tangent, which is y over x, would be 1. Now you're going to get out your graphing calculator and converting angles from degrees to radians. I'm in degrees. I multiply by pi over 180. My degrees cancel out. So my answer, since I started out negative, this is going to be negative pi over 6. And I do leave the pi in my answer. 126 degrees is 7 pi over 10. How did I get there? 126 times pi over 180. The 126 over 180 simplifies to 7/10. Converting from radians to degrees, I multiply by 180 degrees over pi. this is equivalent to 1. I can multiply anything times 1. So 13 pi over 6, my pi's cancel out. 13 times 180 divided by 6 is 390 degrees. 16 pi over 9, I multiply it by 180 degrees over pi. My pi's cancel out. This simplifies to 320 degrees. Find the length of an arc in a circle with a radius given a central angle. Now this formula, you have to be in radians. Okay, so the arc length must be in radians. So you have to convert to radians. So I have 65 degrees. I convert that to radians. I have 13 pi over 6. I then multiply that. So my radius times my central angle, 2.836, and my units were yards. I am still using yards. Here, this is in inches. My answer will be in inches. 330 degrees times pi over 180, because I want to convert from degrees to radians. So I have 11 pi over 6 times my radius is 76.372 inches. And that is the arc length. So what this would look like, well, this would be a little bit easier to look like, to work with. Here I have 65 degrees. My radius is 2.5 yards. And I want to know, what is this arc length? You know, if it was a circle, it'd be part of a circle. And so that arc length was 2.836. Here's a word problem. You will have a word problem on your test. But it will not be like this one. So this one, we have a 10th floor building downtown. It's 105 feet, so it's 105 feet tall. The window cleaners have a 120-foot ladder against the building, and we're looking for an angle with the ladder and the building. In order to find that, I have the cosine of theta. I'm solving for theta now, and when I go to solve for theta, I'm going to use the inverse cosine function. I would like you to pay attention to this and be aware of how to do this. And you probably know it from geometry, but this is something that you do need to know. So we end up, it asked round to the closest degree, so a 29-degree angle. When you're doing this, you want to make sure that your calculator is in degree mode. Let's take a look at the next few problems, but I'm going to pause the recording.